Tonight, you can let the sound of rain settle gently into your imagination. There is nowhere else you need to be, and nothing important you need to remember. You can simply listen as the world becomes quieter. Rain begins with water that is already moving through the atmosphere. Some of it once rested in oceans, rivers, lakes, soil, leaves, or snow. Warmth lifted that water into the air as invisible vapor. High above the ground, the air becomes cooler. Water vapor begins to gather around tiny particles of dust, salt, smoke, or pollen. These particles give the moisture a surface where it can slowly collect. A cloud may look soft and weightless from below, yet even a small cloud can contain an enormous amount of water. The droplets are simply so tiny that rising air can keep them suspended. Most cloud droplets are far smaller than ordinary raindrops. They drift, collide, and sometimes join together. Slowly, a few droplets grow heavy enough to begin falling toward the earth. Not every falling droplet reaches the ground. Some evaporate while passing through dry air beneath the cloud. From a distance, this can create pale streaks that seem to hang below the sky. These fading curtains of rain are sometimes called virga. They are common in dry places, where moisture falls from clouds but disappears before touching the landscape. The rain becomes vapor again, continuing its quiet journey. There is no need to hold on to every detail. You can let each thought arrive like a drop against a window, then slide gently out of view. The shape of a raindrop is different from the familiar teardrops seen in drawings. Very small drops are almost perfectly round because surface tension pulls the water inward. Larger drops flatten slightly as air pushes against them while they fall. If a drop grows too large, the pressure of the moving air can make it unstable. It may stretch, wobble, and divide into several smaller drops. Rain is constantly reshaping itself as it travels downward. Different raindrops fall at different speeds. A light mist drifts slowly and may be carried sideways by the smallest breeze. Larger drops move faster and often make deeper sounds when they meet roofs, leaves, or pavement. The sound of rain is really a collection of many tiny impacts. Each surface gives the water a different voice. Rain on glass sounds bright, while rain on soil is softer and more distant. Leaves add their own rhythm. A drop may strike the upper surface, gather with other droplets, then fall again from the tip. In a forest, the rain can continue dripping long after the cloud has moved away. Rainfall beneath trees is not evenly spread. Branches and leaves catch some water, guide some toward the trunk, and release the rest in scattered drops. The forest floor receives rain through many slow and winding paths. Some rain travels down the bark of trees. This movement is called stem flow. It directs water toward the roots, where the soil can absorb it gradually. The smell that often appears when rain reaches dry ground has a scientific name. It is called petrichor, a word created to describe the earthy scent released after a dry period. The smell comes from several natural substances waiting on rocks and soil. Plants release oils that can settle on dry surfaces. Soil-dwelling bacteria also produce a compound called geosmin. Humans can notice geosmin even when only a very small amount is present. When raindrops strike porous ground, they trap tiny bubbles of air. Those bubbles rise and burst, carrying microscopic scented particles into the air. A gentle shower can spread the smell of the earth surprisingly far. Sometimes the scent arrives before the rain itself. Wind, moving ahead of a storm, can carry moist air, plant oils, and soil particles toward you. The landscape may seem to announce the approaching rain in advance. If your eyes feel heavy, you can let them close. The story will keep moving softly, like water following a quiet path through the night. Rain can clean particles from the air. As drops fall, they gather dust, pollen, and other tiny materials. This is one reason the air may feel clearer after a steady shower. The first rain after a long, dry spell may contain more collected particles. As the shower continues, the atmosphere is gradually washed. Later, rainfall can arrive through air that has already become cleaner. Rainwater is not completely pure. Even before reaching the ground, it can contain dissolved gases, sea salt, dust, and other natural materials. Its exact composition depends on the air through which it has traveled. Ordinary rain is naturally a little acidic. Carbon dioxide in the atmosphere dissolves into water droplets and forms a weak acid. This natural acidity is mild and has always been part of the water cycle. Rain also carries small amounts of nutrients. Nitrogen compounds can be brought from the atmosphere into soil, where plants and microorganisms may use them. A storm can quietly connect the sky with life below. Lightning can help change nitrogen gas into forms that enter the soil more easily. The rain then carries these compounds downward. In this way, a storm can leave behind more than water. A light rain and a heavy rain may come from very different kinds of clouds. Thin, layered clouds often bring long periods of gentle rainfall. Tall clouds with strong rising air can produce larger drops and shorter, more intense showers. The quietest rain may fall from a sky that looks almost motionless. Inside the cloud, however, air and water are continually moving. Droplets form, disappear, freeze, melt, collide, and begin again. In colder clouds, rain can begin as ice. Tiny crystals grow high above the ground, then fall into warmer air and melt. A drop reaching your window may have started its journey as a snowflake. Many clouds contain both liquid droplets and ice crystals. Water can remain liquid even below the normal freezing point when no suitable surface begins the freezing process. This supercooled water plays an important role in forming precipitation. Ice crystals can grow by collecting water vapor from nearby droplets. As they become heavier, they fall. If the air below is warm enough, they melt completely and arrive as rain. A single shower can pass through several layers of air. Each layer may have its own temperature, humidity, and wind direction. The path of a raindrop is rarely straight or simple. Wind can carry drops far from the place where they first began falling. This is why rain sometimes reaches the ground at an angle. Strong winds can make the shower seem to move like a pale curtain across the land. From far away, rainfall may appear to have a clear edge. One side of a street can be wet, while the other remains dry. The boundary between rain and no rain can sometimes be surprisingly narrow. Small summer showers often behave this way. They may form over one neighborhood, release their water, and disappear while nearby skies remain bright. Rain can be local, brief, and almost private. For now, you can imagine a gentle shower continuing beyond the window. The clouds move slowly, the ground darkens, and each drop becomes part of a much older cycle. Water falls, gathers, sinks, flows, and rises again. Nothing in the cycle is hurried, even when the rain itself seems fast. Every drop is simply passing through another quiet stage of its journey. When rain reaches the ground, its journey changes again. Some water rests briefly on leaves, stones, rooftops, and roads. some begins moving at once toward lower places. Dry soil can absorb the first drops quickly. Water enters tiny spaces between grains of sand, clay, and organic matter. This slow movement into the ground is called infiltration. Different soils absorb rain at different rates. Sandy soil contains larger spaces, so water usually passes through it more easily. Clay soil has smaller spaces and often absorbs water more slowly. The condition of the ground also matters. Soil covered with roots, fallen leaves, and grass can receive rain more gently. Bare soil is more easily struck and disturbed by falling drops. A single raindrop may loosen tiny particles of earth. During heavy rain, millions of drops can move soil downhill. Plants help reduce this movement by softening impacts and holding the ground together. Some water remains near the surface, where plant roots can reach it. This stored moisture supports grasses, flowers, forests, and crops. Much of the green world depends on rain held quietly inside the soil. Roots do more than drink water. They create channels in the earth, allowing later rainfall to travel deeper. Worms, insects, and other small animals create additional pathways. As water moves downward, it may reach layers of rock and sediment. There, it can collect underground as groundwater. This hidden water may remain below the surface for months, years, or much longer. Groundwater does not usually sit in large underground lakes. Instead, it fills pores and cracks inside soil and rock. The water moves slowly through these narrow spaces. The upper level of this saturated ground is called the water table. After long periods of rain, the water table may rise. During dry seasons, it can slowly fall again. Some underground water eventually returns to the surface. It may emerge from a hillside as a spring, feed a wetland, or quietly enter a riverbed. The stream can continue flowing long after the rain has stopped. This steady contribution is called base flow. It helps rivers survive between storms. What looks like ordinary stream water may include rain that fell many seasons earlier. There is no need to remember these names. You can simply imagine the water moving downward, slowly and patiently, through dark layers of earth. When the ground cannot absorb rain quickly enough, water begins flowing across the surface. It gathers in shallow paths, joins other moving water, and forms small streams. Each little channel follows the pull of gravity. At first, the flow may be almost invisible. A thin sheet of water crosses a path or garden. Then it collects in grooves, roadside drains, and natural hollows. Small flows become larger as they meet. They move toward creeks, rivers, lakes, and eventually the sea. Much of a river begins as rain spread across a wide landscape. Every river has an area of land that drains into it. This area is called a watershed. A ridge, hill, or mountain can divide one watershed from another. Rain falling on opposite sides of the same hill may travel toward different oceans. The drops begin only a short distance apart, yet their paths slowly separate. One may move east, while another moves west. Mountains strongly influence where rain falls. Moist air is pushed upward when it meets rising land. As the air climbs, it cools, and water vapor can condense into clouds. The windward side of a mountain often receives more rain. After crossing the summit, the air descends and becomes warmer and drier. This can create a rain shadow on the far side. Some deserts exist partly because mountains block moist air. The dry land may lie surprisingly close to forests, rivers, or snowy peaks. Geography can shape rainfall over great distances. Coastal regions often receive moisture from nearby seas. Warm water adds vapor to the air, and winds carry it inland. The ocean becomes a quiet source for clouds that later release rain. Farther inland, rain may depend more strongly on seasonal winds. Some regions experience monsoons, where wind patterns shift during the year. These shifts can bring months of dry weather, followed by a rainy season. A monsoon is not a single storm. It is a broad seasonal change in wind and moisture. Many different showers and storms can occur within one monsoon period. In tropical places, rainfall often follows daily heating. The sun warms the ground. Rising air forms clouds, and afternoon rain becomes common. Evening may arrive with wet streets and cooler air. Near the equator, warm air and abundant moisture support frequent rain. Some forests receive rainfall during much of the year. Their leaves, soils, rivers, and clouds remain closely connected. Trees can help return water to the atmosphere. They draw moisture from the ground and release it through tiny openings in their leaves. This process is called transpiration. A large forest can send enormous amounts of water vapor into the air. Some of that moisture forms new clouds and falls again as rain. Forests do not merely receive rainfall, they also help recycle it. In this way, water can pass repeatedly between soil, roots, leaves, and sky. A drop may enter a tree, rise through its trunk, and return to the air. Later, it may fall again many miles away. If your thoughts begin to wander, that is perfectly natural. You can let them drift like low clouds, without following where they go. Rainfall also changes with the seasons. In some places, winter brings long, quiet periods of rain. In others, summer heat produces brief showers with larger drops. Cold air can hold less water vapor than warm air. This does not mean cold places are always dry, but temperature influences how much moisture the atmosphere can carry. When warm, moist air cools, it reaches a point where condensation begins. Meteorologists call this temperature the dew point. A high dew point means the air contains a great deal of moisture. Before rain, the air may feel heavy because humidity is high. Skin does not cool as easily when moisture is already abundant. The world can seem still, close, and expectant. A breeze may arrive as rain-cooled air sinks from a cloud. This cooler air spreads outward near the ground. Sometimes, you can feel the change before the first drops appear. Rain itself cools the air in several ways. Falling water may evaporate, and evaporation uses heat from the surrounding air. The cooler air then settles closer to the ground. This is why a summer shower can bring sudden relief. Pavement darkens, leaves bend beneath droplets, and warm air slowly loses its sharpness. The whole landscape seems to exhale. Afterward, shallow puddles begin reflecting the sky. Each one creates a temporary mirror, holding clouds, streetlights, branches, and windows. These small surfaces last only until the water drains or evaporates. Evaporation returns rain to the atmosphere without any visible movement. Individual water molecules escape from the surface and enter the air. Warmth, wind, and dry conditions help this happen more quickly. A puddle may disappear, but its water is not gone. It has only become invisible again. The same moisture may later join another cloud and another quiet shower. Rain is always temporary in one place, yet the water cycle continues without a true beginning or ending. The same water has moved through countless clouds, rivers, plants, and living bodies. For now, you can let that cycle continue without your attention. The streams can keep flowing, the soil can keep drinking, and the clouds can gather softly in the distance. The sound of rain can feel soothing because it is steady, gentle, and difficult to predict completely. Each drop adds a small variation, yet the overall pattern remains calm. The mind hears change without needing to follow it closely. Rain creates what scientists sometimes describe as broadband sound. It contains many overlapping frequencies rather than one clear musical tone. This can soften the contrast between sudden noises in the surrounding environment. A passing car, a closing door, or a distant voice may seem less noticeable. The rain does not remove those sounds. It simply places them inside a wider, more continuous background. This gentle masking effect can make a room feel more private. The world beyond the window seems farther away. Attention begins to rest on the soft, repeating texture of water. Rain sounds different depending on the size of the drops. Fine drizzle creates a light, delicate hiss. Larger drops produce deeper taps and brief splashes. A metal roof makes each impact bright and clear. Glass gives the drops a softer click, followed by the quiet movement of water. Leaves create an uneven rhythm as they bend and release collected moisture. On a lake, rain produces countless tiny rings. Each drop pushes the surface downward, then sends ripples outward. The circles overlap until the water appears covered with moving patterns. Heavy drops can briefly trap air beneath the surface. The trapped air forms small bubbles, which may vibrate and release faint sounds underwater. Fish and other aquatic animals can sense these changes. Rain reaches rivers differently. The flowing surface is already moving, so each impact disappears quickly into currents. Along the banks, however, the water darkens soil and loosens the scent of plants. A river may begin rising hours after distant rain. Water needs time to move through slopes, streams, and underground layers. A clear sky overhead does not always mean the river has stopped receiving a storm. The delay depends on the landscape. Steep, hard ground sends water toward rivers quickly. Flat land, forests, and absorbent soil slow the journey. Wetlands are especially good at holding rainwater. Their plants in soft soil store water, reduce sudden flooding, and release moisture gradually. They act like living spaces between land and water. A marsh may appear quiet and still. Below the surface, roots, mud, insects, and microorganisms are constantly changing the water. Rain brings new oxygen, nutrients, and small particles. Ponds also respond quickly to a shower. Fresh water enters from above and from the surrounding ground. The surface cools, and the upper layers may mix with water below. Some small animals become more active during rain. Earthworms may appear on the surface when the soil becomes wet enough for easy movement. Moist conditions also protect their delicate skin from drying. They do not usually rise because they are drowning. Earthworms can survive in water for a time if enough oxygen is available. Rain simply gives them safer conditions for traveling above ground. Snails and slugs also benefit from damp weather. Moisture allows them to move without losing as much water from their bodies. A rainy night can become a quiet period of exploration. Frogs often become more noticeable after rain. Many species depend on temporary pools and fresh water for breeding. Their calls can fill the evening as the landscape becomes wet. The timing of rainfall can influence entire generations of animals. A pond lasting several weeks may allow young frogs to develop. If it dries too soon, their small world disappears before they are ready. In dry regions, some animals wait underground for long periods. They become active when rare rain softens the soil and fills shallow pools. A desert that seemed empty can briefly become full of movement. Seeds may also wait for rain. Some remain dormant in the ground until moisture and temperature are suitable. After a storm, green shoots can appear across land that looked lifeless. Desert flowers often grow and bloom quickly. Their brief season follows water rather than a fixed calendar date. The landscape responds when the conditions are finally right. There is no need to picture every detail clearly. You can let the rain move through forests, ponds, and sleeping fields without following its path. Plants detect rainfall in many quiet ways. Water changes the pressure inside their cells, softens dry tissues, and dissolves nutrients in the soil. Roots respond as moisture becomes available nearby. Some leaves are shaped to remove water quickly. Pointed tips guide droplets away before too much moisture collects. This is common among plants living in very wet forests. Other plants are covered with waxy surfaces. Water forms rounded beads and rolls away, carrying dust with it. A rain shower can leave the leaves looking cleaner and brighter. Tiny hairs can also change how rain behaves. They may slow droplets, protect the leaf surface, or hold a thin layer of air. Every plant meets rainfall through its own structure. Flowers sometimes close before or during rain. Closing can protect pollen from being washed away. Once conditions become drier, the petals may open again for insects. Rain can reduce the activity of many pollinators. Bees usually avoid flying in heavy showers because wet wings make flight difficult. Light rain, however, may not stop every determined visitor. Birds often seek shelter beneath thick branches. Their feathers provide protection, but long exposure can make flying harder. Many birds remain still, conserving warmth until the shower weakens. Some birds appear to bathe in gentle rain. They spread their wings, lift their feathers, and allow water to reach the skin. The shower can help loosen dust and support feather care. Feathers are carefully arranged structures. Their tiny branches connect like a zipper, creating a smooth surface. Birds spend time restoring the structure after wet weather. Rain changes the behavior of insects as well. Flying insects may hide beneath leaves, bark, stones, or buildings. Others take advantage of the moisture and become easier to hear. Mosquitoes are small enough to survive impacts that seem enormous compared with their bodies. A raindrop may push a mosquito downward, but it often slips free before reaching the ground. Its light body prevents the impact from becoming as damaging as expected. Ant colonies are built with rain in mind. Entrances, tunnels, and chambers can direct water away from important areas. Workers may move food or young ants when the ground becomes too wet. The soil itself changes after rainfall. Air inside small pores is displaced as water enters. This alters the underground environment for roots, fungi, bacteria, and tiny animals. Fungi often become more visible during damp periods. Their hidden networks already extend through soil and wood. Rain provides moisture that allows mushrooms to grow above the surface. A mushroom is only part of a much larger organism. Most of the fungus remains as fine threads beneath the ground. The visible shape helps release spores into the surrounding air. Raindrops can help spread those spores. The impact of water creates small movements of air around the mushroom. Spores may be lifted and carried toward new places. Rain can also release pollen and microorganisms from plant surfaces. Some rise into the air again through splashes and bubbles. The atmosphere above a wet forest contains traces of life from below. Clouds themselves can contain living cells, bacteria, fungal spores, and other microscopic material can travel through the atmosphere. Some particles may even help water droplets or ice crystals begin forming. The boundary between Earth and sky is less separate than it appears. Wind lifts particles upward, clouds carry them, and rain returns them to the ground. The air is part of the landscape's living cycle. As evening settles, rain can change the colors of the world. Wet roads reflect lamps, windows, and passing clouds. Dark surfaces become richer, while distant lights stretch into long, trembling shapes. Water fills tiny cracks in stone and pavement. This makes the surface reflect light differently, often appearing darker. The familiar street briefly becomes a quieter and more polished place. Inside, the window gathers its own small rivers. Droplets meet, grow heavier, and slide downward. Each one leaves a thin path that slowly disappears. You do not need to know where any drop is going. The night can hold the rain for you, while every soft sound becomes part of the background. Rain can sometimes begin so gently that the world changes before the drops are noticed. A faint mist settles on windows, darkens leaves, and softens distant outlines. The air seems to become quieter without any clear beginning. Drizzle is made of very small drops. Because they fall slowly, even a light breeze can carry them sideways. Their movement feels less like falling and more like drifting. Fog and drizzle are closely related. Both are made from tiny suspended droplets. Fog remains near the ground, while drizzle slowly grows large enough to descend. On hills and mountains, clouds may touch the land directly. Trees, rocks, and buildings disappear into pale moisture. Water collects on every surface, even when little rain is falling. Some forests receive important moisture from fog. Droplets gather on needles and leaves, then fall to the soil below. This process can support plants during seasons with limited rainfall. Tall coastal trees are especially good at collecting fog. Their branches interrupt the moving air and capture suspended water. The forest creates its own quiet shower beneath the cloud. Rain can also fall while sunlight is still visible. A nearby cloud may release water while the sun shines through clearer air behind you. These moments are often called sun showers. Sunlight passing through raindrops can create a rainbow. The light slows and bends as it enters the water, reflects inside the drop, then bends again as it leaves. White sunlight contains many colors. The raindrop separates those colors because each wavelength bends by a slightly different amount. The result appears as a smooth arc across the sky. A rainbow is not located in one fixed place. Its position depends on the observer, the sunlight, and the falling water. Two people standing apart do not see exactly the same rainbow. The center of the rainbow lies opposite the sun. This is why rainbows are easier to see when the sun is low behind you. Morning and evening often provide the best angles. A full rainbow is actually a circle. From the ground, the horizon usually hides the lower part. From a high aircraft, more of the circle can sometimes become visible. Every visible color comes from different raindrops. A drop sending red light toward your eyes sends other colors in different directions. The rainbow is formed by countless drops working together. Sometimes a second arc appears outside the first. This secondary rainbow forms after light reflects twice inside the drops. Its colors appear in the reverse order and are usually fainter. The sky between two rainbows can look darker. Light is redirected away from this region by the geometry of the drops. The contrast makes the quiet space between the arcs easier to notice. A rainbow can also form in mist, sea spray, or the spray of a waterfall. Only sunlight and suspended water are needed. The same gentle physics appears wherever light meets small droplets. Moonlight can produce a rainbow as well. A moonbow is usually pale because moonlight is much dimmer than sunlight. Human eyes may see it as nearly white in the darkness. Cameras can sometimes reveal more color than the eye notices. A long exposure collects faint light over several seconds. The hidden colors become clearer, while the night remains soft and still. There is no need to keep every image. You can let the colors fade, leaving only the quiet sound of water in the distance. Rain is observed in many different ways. A simple rain gauge collects water inside a measured container. The depth tells us how much rain has fallen over a level surface. The gauge must be placed carefully. Buildings, trees, and strong winds can change how much water enters it. An open location usually gives a more reliable measurement. Weather radar studies rain from far away. It sends pulses of energy into the atmosphere and listens for echoes. Raindrops, snowflakes, and ice return part of that energy. Stronger echoes often suggest heavier precipitation. The shape and movement of the returning signal can also reveal where a storm is traveling. The rain becomes visible as patterns across a map. Radar does not watch individual drops. It observes large regions filled with water and ice. A quiet screen of colors represents countless small journeys through the sky. Weather satellites look down from much higher above. They observe cloud temperatures, shapes, and movement across oceans and continents. Their view connects distant storms into one broad picture. Some satellites can estimate rainfall by studying microwave energy. Water and ice interact with this energy in measurable ways. Scientists use these signals to study rain where ground instruments are unavailable. This is especially useful over oceans. Most of Earth's surface is far from ordinary weather stations. Satellites help reveal rainfall over places where few people ever see it. Ocean rain is part of a vast exchange of heat and moisture. Warm seas feed vapor into the atmosphere. Later, clouds return fresh water to the surface. Rain falling into the ocean slightly changes the water near the top. For a short time, the surface may become cooler and less salty. Waves and currents gradually mix it with the water below. The impacts of many drops also affect the ocean's skin. They create tiny ripples and disturb the smooth surface. From above, patches of heavy rain can change how the sea reflects light. Seabirds may continue flying through gentle rain. Others rest on the water or return toward sheltered coasts. The ocean remains active beneath the changing sky. On land, rain changes human spaces in quieter ways. Roof gutters collect water and guide it toward drains, tanks, or gardens. A building becomes part of the water's path. Some homes store rainwater for later use. The collected water can support gardens, cleaning, or other needs. In suitable systems, it may also be treated for household use. Cities contain many hard surfaces. Roads, sidewalks, and rooftops do not absorb water like soil. Rain moves across them quickly toward channels and underground pipes. Storm drains carry water away from streets. Many lead toward rivers, lakes, or the sea. Whatever enters the drain may eventually reach a natural body of water. Parks and planted areas help slow this movement. Their soil absorbs part of the rainfall, while roots create spaces for water to enter. Even small green areas can change how rain travels through a city. Some streets include gardens designed to collect runoff. These shallow planted spaces hold water temporarily. The rain sinks into soil instead of moving immediately into drains. Permeable pavement works in a similar way. Small openings allow water to pass through the surface. Beneath it, layers of stone can store and slowly release the rain. Green roofs place soil and plants above buildings. They absorb some rainfall, cool the roof, and provide small habitats. Water that does leave the roof travels more slowly. Rain barrels offer another simple method. They collect water from gutters during a storm. Later, the stored rain can be released gently into a garden. In older cities, rain has shaped stone over many years. Water follows the same edges, steps, and channels again and again. Small marks gradually appear where countless drops have passed. Statues and buildings slowly weather beneath rain. Water enters tiny pores and cracks, carrying dissolved minerals. The changes may be almost invisible from one season to the next. When temperatures fall below freezing, water inside cracks can expand. Repeated freezing and thawing slowly widen the spaces. Rain, ice, and time work together to reshape stone. Natural cliffs change in similar ways. Rainwater enters fractures, loosens particles, and feeds plants growing in narrow openings. Even solid rock participates in the water cycle. Some rainwater becomes slightly acidic as it passes through soil. It can slowly dissolve certain rocks, especially limestone. Over long periods, this creates caves, channels, and underground spaces. Cave formations begin with this moving water. Drops carry dissolved minerals from the rock above. When the water enters open air, some minerals are left behind. A stalactite grows downward from a cave ceiling. A stalagmite grows upward from the floor beneath it. Their growth can be extremely slow and continue for thousands of years. Each drop adds a nearly invisible layer. The cave keeps a record of water moving through the land. Its stone shapes are built by repeated, patient rainfall. Inside some caves, ancient mineral layers preserve information about past climates. Their chemistry can reflect wetter or drier periods. Rain that fell long ago remains recorded in stone. Ice can preserve rainfall too. In cold regions, snow builds layer upon layer and slowly becomes glacier ice. Trapped air and chemical traces offer clues about the atmosphere of the past. Rain, snow, rivers, caves, and oceans are all connected. They are different moments within the same movement of water. Nothing needs to remain in one form forever. Tonight, the rain can continue beyond your attention. It can move over rooftops, through soil, beneath stone, and back toward the open sky. Rain does not fall evenly across the planet. Some places receive water almost every day, while others may wait years for a meaningful shower. The pattern depends on oceans, winds, mountains, temperature, and latitude. Near the equator, warm air rises throughout much of the year. As it rises, it cools and forms tall clouds. Frequent rainfall supports dense forests and rivers that remain full across the seasons. Farther north and south, broad regions of descending air are much drier. This helps explain why many of the world's great deserts lie within similar bands of latitude. The atmosphere quietly shapes where water is likely to return. Deserts are not always completely without rain. Some receive brief showers that vanish almost as soon as they arrive. Others may experience rare storms that transform the ground for a short time. Rain over dry land can have a distinct scent and sound. Drops strike dust, stone, and hard soil with sharp clarity. Small channels appear, carrying water through places that seemed unchanged moments earlier. In very dry regions, rain may fall from a cloud but disappear in the hot air below. From a distance, the streaks can resemble curtains hanging beneath the sky. The ground remains dry while the atmosphere completes the cycle above it. Other regions are shaped by long rainy seasons. Warm ocean air moves inland for weeks or months, feeding repeated showers. Rivers rise, fields become saturated, and daily life adjusts to the returning water. Seasonal rain can guide planting, migration, and animal behavior. Many ecosystems have developed around a familiar rhythm of wet and dry periods. Life waits quietly for the moisture it has learned to expect. Temperate regions often receive rain throughout the year. The storms may arrive from moving weather systems rather than one fixed season. A gentle spring shower feels different from cold winter rain. Even when the water follows the same cycle, spring rain often falls onto soil that is beginning to warm. Seeds absorb moisture, roots become active, and new leaves open. The landscape responds gradually, one small change at a time. Summer rain may come from clouds built by rising warm air. The day grows humid, towers of cloud appear, and a shower passes through. Afterward, the air can feel cooler, and the colors of plants more vivid. Autumn rain meets leaves that are already changing. Water gathers on red, yellow, and brown surfaces before carrying some of them to the ground. The sound beneath trees becomes softer and more layered. Winter rain often feels quieter. The sun is lower, plants are resting, and fewer insects move through the air. Drops may remain on bare branches long after the shower ends. In cold conditions, rain can change into sleet, snow, or freezing rain. The form depends on the temperature of different air layers between the cloud and the ground. A small difference can create a completely different landscape. Freezing rain begins as liquid water. When the drops touch surfaces below freezing, they form a layer of clear ice. Branches, roads, and wires become coated with a smooth, glass-like surface. Sleet follows another path. Snow melts while falling through warm air, then refreezes before reaching the ground. The result is small pellets of ice rather than ordinary raindrops. Snow can begin in the same cloud as rain. The difference is simply whether the frozen crystals melt during their descent. One cloud may send snow to a mountain and rain to a warmer valley below. Rain can even fall from clouds that contain hail. Hailstones grow inside strong rising air, where they are carried through layers of liquid water and ice. They eventually become too heavy for the cloud to hold. Most rain, however, arrives without anything dramatic. It forms in ordinary clouds, crosses the air, and reaches the ground as a familiar sound. Its quietness is part of what makes it comforting. There is no need to remember how every kind of rain forms. You can let the names and processes fade while the steady pattern continues in the background. Meteorologists describe rain in several gentle categories. Drizzle is fine and light. Showers begin and end more suddenly, while steady rain may continue with little change for hours. A shower can move across the landscape like a traveling shadow. The distant view becomes blurred. Then the rain arrives overhead. A few minutes later, the brightness returns behind it. Steady rain feels more settled. The cloud layer stretches widely, and the sound remains almost unchanged. Time becomes harder to measure when the same soft rhythm continues. Rain can also be intermittent. It begins, weakens, and returns again. Each pause leaves water hanging from roofs, branches, and wires. The first drops after a pause often sound larger. They land on surfaces that are already wet, creating rounded splashes. Then the quieter background gathers again. Human hearing is sensitive to these small changes. The brain notices patterns, but rain rarely demands a response. It offers variation without requiring attention. This may help explain why rain sounds are often used for sleep. A continuous natural sound can reduce the contrast between silence and sudden noise. The room feels more stable, even while the weather keeps moving. Rain can also create a sense of shelter. Hearing water outside while remaining dry indoors highlights the boundary between the room and the wider world. Walls, blankets, and windows feel more present. The effect is partly emotional rather than purely scientific. People connect rain with memories, seasons, homes, journeys, and quiet evenings. The same sound can mean something different to every listener. For one person, rain may recall a childhood bedroom. For another, it may bring back a train ride, a forest cabin, or an afternoon spent reading. Water becomes part of the memory's atmosphere. Smell is especially powerful in memory. The scent of wet soil, pavement, wood, or leaves can return an old moment with surprising clarity. The memory may arrive before its details do. Rain changes the way places feel. A busy street becomes reflective and subdued. A garden becomes deeper in color, while distant buildings soften behind moving water. Familiar sounds also change. Tires make a gentle hiss, footsteps become quieter, and gutters begin their steady flow. The entire environment gains a new layer of sound. Umbrellas create small private spaces. Rain taps above the head while the world remains visible beyond the curved fabric. Each person carries a temporary roof through the weather. Windows create another kind of distance. Drops move down the glass, bending lights and shapes outside. The room stays still while the view slowly shifts. Rain can make artificial light appear warmer. Lamps and windows reflect across wet surfaces, stretching into soft lines. The colder the night seems outside, the more welcoming indoor light can feel. Artists have long used rain to change the mood of a scene. It can suggest quiet, renewal, loneliness, comfort, or reflection. The weather becomes part of the story without speaking. Musicians sometimes imitate rain with repeating notes and delicate percussion. The pattern may begin sparsely, grow fuller, then fade again. It follows the same shape as a shower passing through. Writers often describe rain because it touches every sense. It can be heard, smelled, felt, and watched. It changes temperature, texture, movement, and light all at once. Yet real rain remains simpler than any description. Water gathers in the sky, falls through the air, and meets the world below. Everything else grows from that quiet meeting. In some cultures, rain is welcomed as a blessing. It brings water to crops, fills wells, and cools the land. Communities may celebrate its arrival after a long, dry season. In other moments, people wait patiently for it to end. Clothes stay damp, roads become slow, and plans move indoors. Rain is both necessary and sometimes inconvenient. The same storm can be experienced in many ways. A farmer may hear relief, a traveler may hear delay, and a child may hear an invitation to step into puddles. Nature does not give rain one meaning. It simply falls wherever the conditions allow. Meaning is added by the lives beneath it. You can let those different experiences drift past without choosing one. Tonight, the rain can be only a soft presence, neither good nor bad, moving gently through the dark. Beyond the room, clouds continue their slow journey. Some are forming over warm water, some are crossing hills, and some are already fading into clear sky. The weather never stops changing, but it does not need your attention. The rain can keep moving through distant seasons. While you rest inside this quiet moment, rain can connect places that are separated by thousands of miles. Water rising from one ocean may travel across continents before returning to the ground. A cloud is part of a journey much larger than the sky above us. Winds carry moisture through broad layers of the atmosphere. Some air currents move gently near the surface. Others travel high above mountains, forests, deserts, and cities. The path of moisture can change from day to day. A small shift in wind may bring rain toward one region and away from another. Weather patterns are always moving, even when the sky appears still. Large ocean currents influence rainfall too. They carry warm and cool water around the planet. The temperature of the sea affects how much moisture enters the air above it. Warm ocean water usually supports more evaporation. More vapor becomes available for clouds, although many other conditions still determine where rain will finally fall. Cool currents can help create dry coastal climates. Air above colder water often remains stable, making tall rain clouds less likely. Some deserts lie beside oceans for this reason. The ocean and atmosphere constantly exchange heat. Sunlight warms the sea, wind stirs its surface, and evaporation carries energy upward. Rain later returns some of that water to the world below. A raindrop falling into the sea becomes difficult to follow. It joins waves, currents, and deeper layers. It may remain in the ocean for a very long time before rising again. Some water is carried toward the poles. There, it may freeze into sea ice or fall as snow. Other water remains warm and continues circulating to tropical seas. The water cycle has no single timetable. Some moisture returns to the atmosphere within hours. Other water stays underground, inside glaciers, or in the deep ocean for centuries. You do not need to follow any one drop. You can let the entire cycle continue as one slow movement around the planet. Rain also carries heat between the atmosphere and the surface. When water vapor condenses into droplets, it releases energy. This hidden transfer helps clouds grow and weather systems develop. The energy was first absorbed during evaporation. Sunlight warmed water at the surface, allowing molecules to escape into the air. The atmosphere later receives that stored energy when clouds form. This process is part of the reason water shapes weather so strongly. It moves not only as liquid and vapor, but also as a quiet carrier of heat. Clouds can form along boundaries between air masses. Warm air may rise over cooler, denser air. As it rises and cools, a broad region of rain can develop. These weather fronts often create long bands of cloud. The rain may continue for hours while the boundary slowly crosses the landscape. Its arrival can feel gradual and settled. A warm front often brings clouds in gentle stages. High. Thin clouds may appear first, followed later by thicker layers and steady rain. The changing sky can begin long before the first drop. A cold front usually moves more quickly. Cool air pushes beneath warmer air and lifts it upward. Showers may arrive suddenly, then clear as the front continues onward. Between weather systems, the atmosphere may become calm. Clouds thin, pressure rises, and the ground slowly dries. The rain leaves behind puddles, damp soil, and cleaner air. Air pressure is simply the weight of the atmosphere above us. It changes as large regions of air move and develop. These changes help guide winds, clouds, and rainfall. Low-pressure areas often encourage rising air. Rising air cools more easily, making cloud formation more likely. High pressure usually favors sinking air and clearer skies. The relationship is not perfectly simple. Local geography, moisture, season, and temperature all shape the final weather. The atmosphere is full of gentle interactions. Even a small island can influence nearby rain. Warm land creates rising air, while hills lift moist winds. Clouds may gather over the island and release showers by afternoon. Cities can influence local weather as well. Buildings and pavement absorb heat during the day. The warmer air above a city may affect cloud growth and nearby rainfall. Tall buildings also change the movement of wind. They create sheltered areas, narrow channels, and swirling currents. Rain may strike one side of a street more strongly than another. A person beneath an umbrella sees only a tiny part of the storm. Above them, the cloud may stretch across many miles. Below, every roof and road sends water along a different path. Rain is both enormous and very small. It can cover an entire region while also gathering as one trembling drop on the edge of a leaf. The surface tension holding that drop together comes from attraction between water molecules. Molecules near the surface are pulled inward by their neighbors. This creates a thin, flexible boundary around the liquid. Surface tension allows water to form beads. It also helps some insects stand or move across the surface of ponds. The water behaves almost like a delicate skin. When rain lands on a waxy leaf, the droplets may remain rounded. On a more absorbent surface, the water spreads outward. The chemistry and texture of the surface decide how the drop behaves. Some leaves are described as water repellent. Their microscopic structure keeps much of the water from touching the surface directly. Droplets roll away, collecting dust as they move. This natural effect has inspired human designs. Researchers study leaves when creating materials that resist water or clean themselves. A quiet rainstorm can reveal useful patterns in nature. Rain also changes the behavior of light at very small scales. Each droplet can reflect its surroundings like a curved mirror. The image is tiny, distorted, and turned by the shape of the water. A drop on a window may contain an upside-down view. Buildings, lamps, or branches appear compressed within it. As the drop moves, the small image moves too. Thousands of droplets create thousands of separate reflections. The window becomes a shifting mosaic of the world outside. Nothing remains clear for very long. Rain softens distant objects for another reason. Drops and mist scatter light as it travels through the air. Colors lose contrast, and faraway edges begin to disappear. The landscape seems to gain depth. Nearby leaves remain dark and detailed, while hills fade into gray. Rain quietly separates the world into layers. At night, these layers can become even softer. Streetlights glow through moisture, and distant signs lose their sharp outlines. The darkness feels less empty because the air itself becomes visible. A light shining through rain reveals drops that were already there. They appear only for a moment, then vanish beyond the beam. The water passes through brightness and returns to darkness. Sometimes rain seems heavier beneath the street lamp. The light does not create more water. It simply makes more of the falling drops visible to the eye. You can allow those drops to pass without counting them. They can enter the light, disappear, and be replaced by others. Rain can continue for hours, while never repeating the same exact pattern. The timing, size, and position of every drop are different. Yet the overall sound remains familiar and calm. This balance between repetition and variation may feel restful. The mind receives enough change to remain gently occupied, but not enough to demand constant attention. The same balance appears in waves, wind, and rustling leaves. Natural sounds often contain patterns that are steady without being mechanical. They continue without forming a perfect loop. A recording of rain can preserve part of this texture. Microphones capture drops on nearby surfaces, distant wind, flowing gutters, and the quiet space between impacts. Different microphones hear different versions of the same shower. One may emphasize deep roof sounds. Another may capture the fine hiss of water moving through leaves. The room where the sound is recorded also matters. Wood, glass, fabric, and stone. Each reflects sound differently. A small shelter creates a more intimate rain than an open field. Real rain surrounds the listener from many directions. It arrives from above, echoes from walls, and moves through drains below. The sound belongs to the entire space. For now, you can imagine that space becoming wider and quieter. Rain falls somewhere beyond the window, while warm air remains still around you. The clouds can travel onward without being watched. The ocean can keep sending moisture into the sky, and the land can keep receiving it. There is nothing you need to guide. Every current, cloud, and droplet can follow its own path while you rest. Rain has shaped the places where people choose to live. Settlements often grew near rivers, springs, lakes, and reliable seasonal rainfall. Water quietly influenced the paths of roads, farms, and cities. Before modern pipes, collecting rain was part of ordinary life. People stored water in jars, cisterns, wells, and underground chambers. Roofs and courtyards were designed to guide every useful drop. Some ancient cisterns still remain today. They were built from stone, brick, or waterproof plaster. In dry regions, stored rain could support a community through many rainless months. The shape of a roof changes how water moves. Sloping roofs send rain quickly toward their edges. Flat roofs require drains or channels to prevent water from gathering too deeply. Traditional buildings often reflect the climate around them. Wide roof edges protect walls in rainy places. Courtyards and tanks help collect water where rainfall is rare and valuable. Rain has also influenced the materials used in homes. Wood, clay, stone, and plant fibers respond differently to moisture. Builders learn which surfaces could dry safely and which needed protection. A building must breathe in its own quiet way. Moisture enters through air, rain, and ground contact. Good design allows that water to leave before it causes lasting damage. Rain falling through a city follows thousands of planned routes. It moves along roofs, balconies, gutters, streets, and hidden pipes. The water joins a network most people rarely notice. Older drainage systems were sometimes built as open channels. Rainwater flowed beside roads or through stone passages. In some places, these channels still guide storms through historic neighborhoods. Modern systems often hide the water underground. Beneath a dry-looking street may be a large tunnel carrying rainfall toward a river. The storm continues below while life moves above it. Some cities separate rainwater from household wastewater. Others use shared pipes for both. During very heavy rain, shared systems can become overwhelmed more easily. Engineers study how quickly rain may arrive. They consider the size of streets, roofs, parks, drains, and nearby waterways. Their goal is to give the water enough space to move safely. Yet water always follows gravity. If one route becomes blocked, it searches for another. A curb, doorway, garden wall, or small slope can redirect an entire stream. Leaves can gather over drains during autumn rain. Water begins pooling around them, reflecting the sky. Once the leaves are cleared, the puddle suddenly becomes a turning current. In colder places, drains must also handle melting snow. The water may arrive days or weeks after the original storm. Frozen precipitation simply delays its movement across the land. Rain and snow together help fill reservoirs. These large bodies of stored water support homes, farms, and industries. Their levels rise and fall with the seasons. Reservoirs are often connected to distant watersheds. Rain falling in quiet mountains may later travel through pipes into a crowded city. A glass of water can begin far beyond the horizon. Treatment systems make collected water safer to use. They remove particles and reduce harmful microorganisms. What begins as cloud moisture passes through many careful steps before reaching a faucet. Water leaving the home begins another journey. It is cleaned again before returning to rivers or seas. Human systems have become part of the wider water cycle. There is no need to imagine every pipe or channel. You can let the rain move quietly beneath streets and through distant hills without following it. Farming has always depended closely on rainfall. Seeds need moisture to begin growing, while roots need water throughout the season. Too little or too much can change the harvest. Farmers watch not only the total amount of rain, they also notice when it arrives, how long it lasts, and how quickly it falls. Gentle rain may soak into soil more effectively than a brief downpour. A slow shower gives water time to enter the ground. Heavy rain may run away before roots can use it. The same amount of water can have a very different effect. Young plants are especially sensitive to dry soil. Their roots have not yet reached deeper moisture. A well-timed rain can support them during the earliest stages of growth. Later, deeper roots may help plants survive between showers. Different crops develop different strategies. Some spread roots widely, while others reach farther downward. Farm soil is often shaped to guide rain. Small ridges, terraces, and channels can slow water and reduce erosion. These simple forms help the land hold moisture longer. Terraces transform steep slopes into steps. Rain moves across each level rather than rushing straight downhill. The design protects soil while giving crops a flatter place to grow. Mulch also changes the path of rain. Leaves, straw, bark, or other material cover the soil surface. This soft layer reduces evaporation and protects the ground from direct impacts. After rainfall, covered soil often remains damp for longer. The water is sheltered from sun and wind. Small organisms beneath the mulch continue working in the moist darkness. Rain can dissolve nutrients already present in soil. The water carries them toward roots, where plants can absorb them. Yet strong rainfall can also wash some nutrients deeper than roots can reach. Too much standing water creates another problem. Water fills the spaces that normally contain air. Roots may struggle because they need oxygen as well as moisture. Plants adapted to wetlands have special ways of coping. Some contain air spaces inside their stems and roots. These structures help oxygen move into waterlogged tissues. Rice is one familiar crop that can grow in flooded conditions. Its fields often hold shallow water, although the plant still depends on careful timing and management. The water also changes which weeds can survive nearby. Other crops prefer dry, well-drained ground. Grapes, olives, and many herbs can struggle when roots remain wet for too long. Every plant has its own relationship with rain. Orchards respond in different ways throughout the year. Winter moisture may support roots before spring growth begins. Rain during flowering, however, can affect pollination and delicate blossoms. Rain near harvest can change fruit as well. Water enters the plant and may alter sweetness, size, or skin tension. Farmers watch the sky closely as crops approach maturity. Grasslands also follow the rhythm of moisture. After rain, grasses grow quickly and provide food for grazing animals. During dry periods, their growth slows and colors fade. Rainfall patterns can guide animal migration. Herds move toward places where fresh plants and water have returned. Their long journeys often follow seasonal changes across the landscape. Birds may follow these green regions too. Rain encourages insects, seeds, flowers, and shallow pools. A storm can create feeding places for many different species. In dry environments, temporary pools are especially important. They may last only a few days or weeks. During that brief time, small animals feed, breed, and complete rapid stages of life. Some tiny crustaceans leave eggs inside dry soil. The eggs remain dormant until rain fills the pool again. Life waits in the dust for water to return. Certain plants use a similar strategy. Their seeds can remain inactive through long, dry periods. Moisture begins chemical changes that allow growth to start. A seed does not simply wake because it becomes wet. Temperature, light, oxygen, and the condition of its outer coat may also matter. Rain is an invitation, but the seed still reads the season carefully. Some seeds even require repeated rainfall. The first shower may soften the outer layer. Later moisture finally reaches the living tissue inside. In forests, rain supports life high above the soil. Water collects in tree hollows, curled leaves, and clusters of plants growing on branches. These small pools become habitats of their own. In tropical forests, some frogs lay eggs near water held by plants. Their young grow inside tiny elevated ponds. A single leaf can contain an entire temporary world. Mosses absorb water across their surfaces. They do not need deep roots to collect moisture. After rain, dry-looking moss can become soft, green, and full again. Lichens respond more slowly, but just as quietly. They absorb moisture from rain and air, then become less active when conditions dry. Their lives move between wet and resting states. Many lichens grow only a few millimeters each year. Rain, fog, sunlight, and clean air support their patient growth. They can remain on stone or bark for decades. Rain also awakens the sense of forests. Wet bark, leaves, soil, and fungi release different compounds. The air becomes layered with quiet signals from living things. Animals use some of these scents for information. Moist air can carry odors differently from dry air. Tracks, territory marks, flowers, and food may become easier to detect. Sound also travels differently in humid conditions. Moisture changes the atmosphere slightly, although wind and temperature matter greatly too. A rainy forest can make nearby sounds feel close and distant ones feel softened. The drops create their own acoustic boundary. Small movements disappear beneath the steady patter. Larger sounds emerge briefly and settle back into the background. You can let the forest remain there without entering it fully. Rain can keep touching leaves, filling small pools and moving through roots while you rest. Across fields and cities, people still look upward when the first drops arrive. Some close windows, some gather laundry, and some step outside to feel the change. The same weather touches many separate lives. A storm may pass over houses where people are reading, cooking, working, or already asleep. Each roof receives the same rain with a different sound. Every room becomes its own sheltered world. Beyond those rooms, the water continues downward. It enters gardens, drains, roots, rivers, and reservoirs. Nothing asks it to remember where it has been. The rain simply keeps moving. And for now, you can remain still while its long journey continues somewhere in the dark. Rain leaves records in places that seem completely still. Tree rings, lake sediments, cave minerals, and layers of ice can preserve clues about wetter and drier years. A tree ring usually reflects one season of growth. When water is plentiful, some trees grow a wider ring. During dry years, the ring may become narrower. The pattern is not controlled by rain alone. Temperature, soil, sunlight, disease, and competition also matter. Scientists compare many trees before drawing conclusions about past weather. Old wood can extend this record far beyond a human lifetime. Living trees are compared with beams, stumps, and preserved trunks. Their overlapping ring patterns can reveal centuries of changing rainfall. Lakes keep another kind of record. Small particles settle slowly onto the bottom, forming layer after layer. Pollen, dust, minerals, and remains of tiny organisms become trapped there. A wet period may carry more soil into a lake. A dry period may change the plants growing nearby. These differences can remain hidden beneath the water for thousands of years. Scientists collect narrow cores from lake beds. The deeper layers are usually older. Each section offers a small glimpse of the landscape and climate that once surrounded the lake. Ocean floors preserve even longer histories. Shells from microscopic organisms contain chemical clues about the water in which they formed. Those clues help reconstruct ancient temperature and rainfall patterns. Caves also remember rain. Water moving through soil absorbs minerals before entering the darkness below. As drops fall, they leave behind thin layers of stone. The chemistry of those layers changes with the water above. Some patterns suggest wetter seasons, while others indicate long dry periods. A cave formation can become a quiet timeline built one drop at a time. Ice sheets contain a different archive. Snow falls, survives the summer, and becomes compressed beneath later snow. Over time, the layers turn into solid ice. Dust and sea salt become trapped inside. Tiny bubbles preserve samples of ancient air. The ice can reveal how the atmosphere changed alongside rainfall and temperature. In this way, water carries memory without being aware of it. Rain becomes wood, mud, mineral, ice, and ocean sediment. The weather of a distant year remains inside the landscape. There's no need to follow the years backward. You can let the old storms remain where they are, resting in stone, wood, and ice. Rain has also influenced the language people use. Many cultures have words for different kinds of rain, from mist and drizzle to heavy seasonal downpours. These words reflect what people notice around them. A place with frequent rain may distinguish between subtle changes in drop size, wind, duration, or season. In another region, the most important difference may be whether the rain arrives early or late. The name becomes connected to crops, rivers, journeys, and daily routines. People often describe rain through sound. It patters, whispers, taps, drums, hisses, and murmurs. Each word tries to capture a slightly different surface and rhythm. Rain on canvas sounds different from rain on wood. Rain on stone carries a harder edge, while rain on grass disappears into a softer texture. Even the same roof changes as a storm develops. The first drops arrive separately. Later, countless impacts blend into one continuous sound. Water gathering in gutters adds a lower tone. Drains begin to gurgle, and nearby puddles create rounded splashes. The sound becomes fuller without becoming musical. A storm heard from indoors contains distance. The roof may sound close, while rain against trees feels farther away. Thunder, traffic, and wind create occasional deeper layers. When the storm weakens, the pattern becomes easier to separate. Individual drops emerge again. Water continues falling from branches after the clouds have moved on. This dripping period can last a long time in a forest. Leaves, bark, moss, and vines release water at different speeds. The rain seems to continue from the trees themselves. Inside a city, buildings create their own delayed rainfall. Balconies, awnings, signs, and wires keep dropping water after the sky begins to clear. A single drop may wait on the edge of a roof. It grows as more water joins it, then finally falls. Another begins forming almost immediately. You can let the rhythm become less distinct now. There is no need to notice each impact. The sound can merge into one soft, continuous presence. Rain sometimes changes the way people sleep. Cooler air can make a room feel more comfortable, especially after a warm day. The steady sound may also reduce the sharpness of distant noises. The effect is not identical for everyone. Some people feel peaceful during storms, while others remain alert. Memory, environment, and personal experience all shape the response. Gentle rain usually feels different from severe weather. A quiet shower changes the atmosphere without demanding action. It creates a sense of movement outside and shelter within. Dark clouds also reduce daylight. In the evening, this can support the natural feeling that the day is closing. The room becomes dim before the sun fully disappears. Rainy weather may encourage slower activities. Reading, resting, listening, and watching the windows seem to match the pace of the sky. The weather gives permission for stillness. Although nothing has actually changed indoors, tasks may remain unfinished, and the world may continue moving. Yet the sound of rain creates a softer boundary around the moment. For children, rain can become play. Puddles reflect the sky and respond instantly to every step. Boots, coats, and umbrellas turn an ordinary street into a different landscape. A puddle may look shallow, but contains several small worlds. Dust settles at the bottom, leaves float on the surface, and tiny insects gather nearby. Birds may drink from its edge. Dogs pause to smell the wet ground. Passing tires send the water outward in brief waves. Soon the puddle begins shrinking. Some water drains away, some enters the soil, and some rises invisibly into the air. Nothing about the puddle is permanent. Its reflection changes with every cloud and movement. By the next day, it may be gone completely. Rain also changes rivers gradually rather than only during storms. Repeated showers keep soils moist and streams connected. The whole watershed responds over days and weeks. When the land is already wet, later rain runs off more quickly. The soil has less empty space available. Rivers may rise faster than they would after a long, dry period. When the ground is dry, the first rain may travel more slowly. Cracked soil begins to swell. Plants absorb water, and shallow depressions fill before streams respond. Very dry soil can sometimes repel water briefly. Natural waxes from plants and microorganisms may coat soil particles. Rain then runs across the surface before slowly soaking in. This effect can be especially important after fires. Without leaves and roots, water moves faster across exposed slopes. Ash and damaged soil can further reduce absorption. Over time, plants return and the ground begins recovering. Roots enter the soil again. Fallen leaves rebuild the surface, and rain becomes easier to hold. Nature is often a process of slow repair. A storm may disturb one place while supporting growth somewhere else. Water moves through both damage and renewal. Rain falling on the ocean creates almost no lasting mark. The surface opens beneath each drop and closes again. For a moment, a circle spreads outward, then disappears into larger waves. From high above, a shower may look like a gray veil moving across the sea. Beneath it, the water darkens and the horizon fades. The storm passes through a landscape with no roads or walls. Some ships can smell rain before it reaches them. Moisture, wind, and changing pressure alter the air over the deck. The approaching shower becomes visible as a darker region ahead. Sailors have always watched clouds closely. Before satellites and radar, the shape, color, and movement of the sky offered essential guidance. Clouds near the horizon could signal changing wind. A halo around the moon might suggest ice crystals in high clouds and an approaching weather system. These signs were never perfect. The atmosphere changes too easily for simple rules. Experience helped people notice patterns without controlling them. Even now, forecasts describe probability rather than certainty. A chance of rain means the conditions make rainfall possible across part of an area. It does not promise that every street will become wet. A cloud may pass nearby without releasing anything. Another may produce a brief shower over only a few buildings. Weather remains local even inside a broad forecast. This uncertainty is part of rain's quiet character. It gathers, moves, changes direction, and falls where the air allows. For tonight, none of that needs to be predicted. The clouds can decide nothing and still continue drifting. The water can fall wherever the night carries it. You can remain here, listening only as closely as feels comfortable. The rain will keep moving softly. Even when your attention begins to fade, rain can also shape the smallest details of daily life. It changes the pace of footsteps, the timing of journeys, and the quiet choices people make indoors. A morning shower may delay a walk by only a few minutes. A long rainy day can gently rearrange the rhythm of an entire neighborhood. Windows are opened less often. Shoes gather near doors. Coats begin to dry, and umbrellas leave small circles of water on the floor. The air inside may feel different. Humidity rises. Fabric holds moisture longer. And familiar rooms become softer in sound. Wood can respond to damp conditions. Doors may swell slightly, floorboards may shift, and musical instruments may need time to adjust. Paper reacts as well. Pages curl, envelopes soften, and books absorb a faint trace of moisture from the surrounding air. Rain changes cooking and eating habits in subtle ways. Warm drinks, soups, and slow meals often feel more comforting when the weather outside is cool and wet. This is partly about temperature. It is also about contrast, with warmth indoors feeling stronger against the damp world beyond the glass. The sound of cooking may blend with the weather. Water simmers, kettles breathe steam, and rain continues tapping quietly in another part of the room. Steam is another form of water returning to the air. It rises from cups, pans, baths, and wet clothes. The same element moves through the home in many gentle forms. Condensation appears when warm, moist air meets a cooler surface. Tiny droplets gather on windows, mirrors, and metal. The room creates its own miniature version of cloud formation. A fogged window clears from the edges first. Temperature and airflow slowly remove the moisture. The outside world returns in pieces. Rain can make indoor light appear more golden. Clouds dim the daylight, and lamps become more noticeable. Shadows soften while corners feel quieter. The human eye adjusts gradually to lower light. Pupils widen, colors become less vivid, and brightness loses some of its sharpness. This gentler light can support relaxation. The brain receives fewer strong visual contrasts. The room begins to feel less active and more enclosed. There's nothing you need to do with that feeling. You can let the room remain quiet while the rain continues without asking anything from you. Rain also affects the way animals seek shelter. A squirrel may stay beneath thick branches. A fox may rest deeper inside a den. Small mammals often avoid unnecessary movement during cold, wet weather. Remaining dry helps them conserve body heat and energy. Some animals use burrows with sloping entrances. The shape reduces the amount of water reaching inner chambers. Soil above them absorbs much of the rain. Other animals choose hollow trees, rock crevices, or dense vegetation. Each shelter changes the sound and temperature of the storm. Inside a burrow, rain may be heard only as a dull vibration. Beneath leaves, it becomes a scattered tapping overhead. For insects, even a small drop can be a major event. Many hide beneath petals, bark, or the undersides of leaves until the surface becomes safe again. Spiderwebs collect rain in delicate beads. The silk bends under the weight, but often remains intact. After the shower, sunlight may reveal hundreds of tiny reflections. Web silk is both strong and flexible. Its structure allows it to stretch without breaking easily. Droplets gather along the threads like a temporary chain of glass. Some spiders rebuild parts of the web after rain. The work begins quietly, strand by strand. the storm becomes another change to respond to. Bird nests are also built with weather in mind. Their woven shapes allow some water to drain, while feathers and body heat protect the young. Many nests are placed beneath branches or ledges. The position reduces direct exposure to rain and strong wind. Water birds respond differently. Ducks and other species have feathers coated with oils that help resist water. They spread these oils carefully during preening. The result is a surface that causes droplets to roll away rather than soaking deeply into the plumage. Beneath the outer feathers lies a layer of trapped air. This air helps insulate the body from cold water and rain. Even so, birds still seek calmer places during intense weather. A sheltered shore, reed bed, or quiet inlet offers protection from wind and waves. Rain can make lakes appear smoother from a distance. At the same time, countless drops are disturbing the surface with tiny impacts. The eye sees one continuous texture. Below it, each ring expands, overlaps, and disappears. Fish may move deeper when the surface becomes noisy. Other species approach shallow water, where rain has carried insects and food. The water near the surface may also cool. This can influence oxygen levels and the movement of aquatic life. In warm ponds, a rainstorm may mix layers that were previously separated. Cooler water sinks while warmer water rises. The pond slowly redistributes heat and oxygen. This mixing can be important for small ecosystems. It changes where organisms find comfortable conditions. Rain entering a pond also dilutes some dissolved materials. The chemical balance shifts slightly and settles as the water mixes. Every pond responds differently. Its depth, temperature, plants, soil, and surrounding land all shape what happens next. Rain can even change the clarity of water. Runoff may carry soil into streams, turning them brown for a time. In forests, tannins from leaves can color water amber. These natural compounds give some streams and ponds a deep tea-like shade. The color does not always mean the water is dirty. It may simply reflect organic material from the surrounding landscape. Mountain streams often clear quickly after rain. Lowland rivers may remain cloudy longer because they carry more sediment. Sediment is part of a river's work. It is moved, deposited, lifted again, and carried farther downstream. Over many years, this movement reshapes valleys and floodplains. River bends migrate slowly as water erodes one bank and deposits material on the other. Rainfall provides the energy that keeps this process active. A river is never exactly the same from one season to the next. Its channels shift, stones move, and new layers of sand appear. Floodplains are built by repeated overflow. During high water, rivers spread fine soil across nearby land. This soil can be rich in nutrients. Many ancient farming communities grew beside rivers for this reason. The same floods that caused disruption also renewed the ground. Human settlements learned to live with both sides of the river. Walls, raised buildings, channels, and seasonal routines developed around the water. Rain has always asked for adaptation. It cannot be controlled completely, but its movement can be understood and respected. Modern forecasts help people prepare. Radar, satellites, weather stations, and computer models work together to estimate what the atmosphere may do. A forecast model divides the atmosphere into a three-dimensional grid. It calculates changes in temperature, wind, moisture, and pressure across that grid. The calculations are repeated many times. Each step offers a possible picture of the coming hours or days. Because the atmosphere is complex, forecasts are not perfect. Small differences in starting conditions can grow over time. This is why short-term forecasts are usually more reliable. The farther ahead we look, the more possible paths the weather can take. Meteorologists compare several model results. When many agree, confidence is higher. When they differ, uncertainty becomes more important. Rainfall is especially difficult to predict precisely. A small shower may form between weather stations or change direction unexpectedly. The forecast may be correct for the region, but different for one street. A person may carry an umbrella beneath dry skies, while rain falls only a few miles away. There is something gentle in that uncertainty. The atmosphere keeps some of its movements beyond exact prediction. Rain arrives through a balance of conditions, too detailed for any one observer to see. Moisture rises, air cools, droplets gather, and gravity completes the journey. You do not need to understand the entire system. You can let the sky remain larger than any explanation. The facts can drift more quietly now. They can become background, like distant water moving through a gutter or stream. Somewhere, rain is beginning over a field. Somewhere else, it is ending above a dark road. A cloud is thinning over the ocean. Another is forming beside a mountain. The water keeps changing place without hurry. And you can let your attention change with it. Nothing needs to be held closely. The rain can continue carrying the story for you. Rain can become part of the landscape almost immediately. A drop landing on dry stone may vanish into a crack, while another rests briefly on a leaf. Some water travels only a few inches before stopping. Other water begins a journey that may continue through rivers, underground layers, and distant seas. On mountain slopes, rain often gathers into narrow channels. At first, these channels may be too small to notice. Over time, repeated flow deepens them into visible paths. Tiny streams join larger ones as they move downhill. Each meeting adds more water, more sediment, and a slightly stronger current. The shape of a valley often reveals where water has traveled for thousands of years. Gentle slopes suggest slow erosion, while narrow valleys may reflect faster-moving streams. Rain does not carve the land quickly in ordinary conditions. Its work is patient, repeated, and usually almost invisible from one day to the next. A hillside may look unchanged after a shower, yet a few grains of soil have moved, roots have absorbed moisture, and small cracks have widened. Over centuries, those small changes become part of the landscape. Cliffs soften, riverbanks shift, and stones lose their sharp edges. Rainwater can also carry dissolved minerals. As it passes through rock, it collects small amounts of material and transports them toward streams. Rivers then carry those minerals toward lakes and oceans. This quiet movement helps connect mountains with coastlines. The ocean receives material from almost every continent. Some arrives in rivers, some through wind, and some directly with rain. Rain falling over the sea may seem to disappear immediately, but near the surface, it briefly forms a layer of fresher water. That layer is gradually mixed by waves and currents. Wind breaks the surface, while deeper water rises and falls beneath it. Rain can calm very small ocean ripples for a moment. At the same time, heavier drops create countless new rings and splashes. From above, a rainstorm over water can appear darker than the sea around it. The falling drops change how light reflects from the surface. Sailors sometimes see the rain before feeling it. A gray veil moves across the horizon, hiding the boundary between ocean and sky. When the shower arrives, the air may cool quickly. the deck darkens, ropes become wet, and the sound of water surrounds the vessel. After the cloud passes, sunlight may return within minutes. The wet surfaces remain, shining under a sky that already looks different. Rain over islands follows patterns shaped by wind and mountains. One side may remain green and wet, while the opposite side receives much less moisture. As moist air climbs, it cools and forms clouds. After crossing the high ground, the air descends and becomes drier. This creates strong contrast within surprisingly small distances. A short drive can lead from rainforest to dry grassland. Plants adapt to these local patterns. Some grow broad leaves where water is abundant, while others conserve moisture with smaller surfaces. In dry climates, leaves may be thick or waxy. These features reduce water loss between rare periods of rain. Some plants store water inside stems or leaves. Others grow deep roots that reach moisture far below the surface. Rainfall influences when plants flower. A shower after a dry season can trigger growth across an entire landscape. Flowers may open almost together. Insects then appear to feed, pollinate, and begin new stages of life. The transformation can be brief. As the soil dries, many plants return to seeds, roots, or resting forms. Rain becomes a signal rather than only a source of water. Its arrival tells living systems that conditions have changed. Some animals respond to the sound of rain. Others detect cooler air, damp soil, or shifts in pressure. Amphibians are especially sensitive to moisture. Many leave shelter places when the ground becomes wet. Their skin must remain moist for important body functions. Rainy nights allow them to travel with less risk of drying. Some frogs call more strongly after rainfall. Their voices spread across ponds, ditches, and temporary pools. The chorus may sound loud, but each animal occupies a small part of the darkness. Rain creates the conditions for that temporary gathering. When the pools disappear, the landscape becomes quiet again. Many insects also time their activity around moisture. Winged ants may leave colonies after rain when the air is humid and the soil is soft. Termites can respond in a similar way. Large groups sometimes emerge at once to begin new colonies. The timing reduces the risk that any one individual will be noticed. It also takes advantage of damp ground that is easier to enter. Rain can make scents stronger near the surface. Moisture releases compounds from soil, wood, leaves, and flowers. Animals use these changing scents to find food and recognize familiar places. The world may smell richer after sunset, when evaporation slows. Cooler air allows moisture to remain close to the ground. You can let these small movements continue without imagining them clearly. The wet grass, quiet ponds, and dark trees can remain softly in the background. Rain changes the way sound moves through a landscape. The falling water creates a steady layer that covers quieter noises. At the same time, wet surfaces reflect and absorb sound differently from dry ones. Forest after rain can feel unusually close. Drops continue falling from high branches long after the main shower has ended. Each level of leaves releases water at a different pace. The highest branches may drip first, followed by lower leaves and moss-covered trunks. The forest creates a second rainfall beneath the clouds. This lower dripping can last for hours. Water gathers in bark, vines, and pockets of leaves before finally reaching the soil. Some of it never reaches the ground directly. It may be absorbed by moss, lichens, or plants growing on branches. These plants use rain without sending roots into the earth. They collect moisture from the air and from water moving across their surfaces. In cloud forests, this process is especially important. The trees stand inside mist for long periods, gathering water from passing clouds. The forest can receive moisture even when no ordinary rain is falling. Droplets condense on leaves and slowly fall downward. This hidden rain supports streams and soils below. A mountain forest may therefore create water from both rain and fog. Its vegetation becomes part of the collection system. When trees are removed, less moisture may be captured. The soil also loses roots and fallen leaves that once slowed water. Rain then moves more quickly across the surface. Streams can rise faster, while less water enters underground layers. Healthy soil behaves almost like a sponge. It stores part of the rain and releases it gradually. Organic matter helps create this structure. Decaying leaves, roots, fungi, and small animals dot spaces where water can rest. The soil remains alive beneath the surface. Even during a quiet shower, countless microscopic processes continue. Bacteria respond to moisture. Fungi extend through damp material, and roots adjust their growth toward available water. A handful of soil can contain many different living communities. Rain changes their activity without making any visible sound. Some microorganisms become active within minutes. Others remain dormant until temperature and moisture are both suitable. The soil breathes differently after rain. Water fills some pores, while air is pushed into others. As the surface dries, oxygen gradually returns. The balance is always changing. Too little water slows life, while too much can limit the air that roots and organisms need. Rain rarely gives every place the perfect amount. One field may receive enough, while another nearby receives far less. Clouds can release water unevenly over very short distances. This is why rainfall measurements vary between nearby locations. One gauge cannot describe every garden or hillside. Weather stations are compared to build a wider picture. Satellites and radar add information from above. Together, they reveal patterns that no single observer could see. Yet even the best map simplifies the rain. It cannot show every drop on every roof, leaf, or river. The real storm remains far more detailed. It unfolds across millions of surfaces at once. For now, that detail can fade into one gentle idea. Water is falling somewhere, meeting the earth, and continuing onward. Some drops are entering soil. Some are joining streams, and some are resting on the edge of a leaf. The rain does not need to know its destination. It simply follows gravity, wind, temperature, and the shapes beneath it. You can let your thoughts do the same. They can arrive, move softly, and disappear without needing to be held. Rain can begin far above the ground in air that feels almost empty. A cloud is not a container filled with ordinary water. It is a wide region where countless tiny droplets remain suspended. These droplets are usually too small to fall as rain. They drift with moving air, joining and separating as the cloud slowly changes shape. Inside warmer clouds, droplets grow by colliding with one another. A slightly larger drop falls faster than the smaller ones around it. As it descends, it gathers more water. This process may happen many times before the drop becomes heavy enough to leave the cloud. Even then, the journey to the ground is not guaranteed. A falling drop may enter dry air and begin evaporating. If it becomes small enough, it disappears completely before reaching the surface. The water has not been lost. It has simply returned to vapor and may become part of another cloud later. In colder clouds, ice often helps rain to form. Tiny ice crystals grow while nearby liquid droplets become smaller. The crystals eventually fall into warmer air and melt. Much of the rain reaching the ground may therefore have begun as snow high above. The drop arriving on a roof carries no visible trace of that frozen beginning. It simply joins the soft rhythm of the shower. Clouds can contain several layers of motion. Warm air rises, cooler air sinks, and winds move droplets sideways through the cloud. A single drop may travel upward and downward more than once. Its path can be curved, interrupted, and much longer than the distance straight to the ground. Strong rising air can keep water suspended for a long time. Gentler clouds release their moisture more gradually. This is one reason some rain arrives as a steady curtain. Other rain falls in scattered bursts with quiet pauses between them. The edges of a shower are often irregular. A few large drops may arrive first, separated by long spaces. Then the sound grows fuller as the center of the cloud moves overhead. Near the end, the pattern begins to open again. Individual drops become easier to hear before the final ones disappear. There may be no exact moment when the rain stops. The shower simply becomes less frequent until the silence returns. Even after the sky clears, water continues moving. Drops fall from cables, leaves, roofs, and branches. A tree may release rain long after sunlight has returned. Its leaves stored part of the shower and now return it slowly to the ground. You can let that slower rhythm remain in the distance. There is no need to notice where one sound ends and another begins. Rainfall is often described by depth. A measured inch of rain means enough water fell to cover a flat surface, 1 inch deep. The actual water does not remain in an even layer. It flows downhill, enters soil, gathers in streams, and collects in lower places. Over a large area, even a shallow depth represents an enormous amount of water. Yet the rain arrives through drops small enough to rest on a fingertip. This contrast is part of the quiet scale of weather. A storm can be vast, while each piece of it remains delicate. Scientists also measure how quickly rain falls. A gentle shower may add water slowly over many hours. A downpour can release a similar amount in a much shorter time. The rate matters because soil needs time to absorb moisture. Slow rain can move downward through the ground. Fast rain is more likely to gather on the surface and flow away. The history of recent weather matters too. Dry soil may have room to accept water. Already saturated soil may send even light rain toward rivers. No shower arrives on an unchanged landscape. The ground remembers previous days through its moisture, temperature, and living roots. Clouds also remember the air through which they formed. Sea salt, dust, smoke, pollen, and microscopic life can all become part of cloud droplets. Some particles make it easier for water to condense. Without tiny surfaces in the air, droplets would need different conditions to begin forming. The atmosphere is never truly empty. It contains traces of oceans, deserts, forests, cities, and distant fires. Rain gathers some of those traces and carries them downward. A drop falling over one landscape may contain material lifted from another place far away. Dust from a desert can cross an ocean. Sea salt can travel inland on the wind. Pollen can rise high into the atmosphere before returning with rain. The sky quietly mixes distant parts of the planet. Rain becomes one way those places touch. There's no need to imagine the distance. You can simply let the air carry what it carries. Rainwater may sometimes appear colored. Fine dust can give it a pale yellow, brown, or reddish tint. The water itself has not changed color. It has collected particles while falling through the atmosphere. After such a shower, cars or windows may be covered with a thin, dusty film. The rain cleaned the air and left the material behind. Ordinary rain performs a smaller version of this cleaning every day. Drops capture particles as they fall. The air afterward may seem clearer, especially after a long, steady shower. Light becomes sharper between clouds. Distant hills may appear closer, and leaves look brighter against the washed sky. Rain can also reduce airborne pollen for a while. Many grains are carried downward and settle onto wet surfaces. After the ground dries, some may return to the air. The pause is temporary, like most changes created by weather. Rain can lower the temperature of streets and rooftops. Water absorbs heat from warm surfaces. Evaporation then removes additional heat as liquid becomes vapor. This cooling may continue after the shower has ended. Wet pavement releases stored warmth differently from dry pavement. A city at night can feel calmer after rain. The air is cooler, traffic sounds softer, and reflected lights replace the brightness of the day. Buildings slowly release the heat they collected earlier. Water moves along their surfaces and into the hidden channels below. In quiet neighborhoods, the loudest sound may come from a single drain. Its steady flow continues after the tapping on windows has stopped. Each building gives the storm a different voice. A tiled roof creates quick, bright impacts. A wooden roof softens them into a lower murmur. Fabric awnings respond with small vibrations. Metal gutters add echoes and flowing tones. Inside a parked car, rain becomes close and surrounding. The roof carries every impact through the enclosed space. Windows blur the outside world into moving shapes and soften light. Inside a tent, the separation feels even thinner. Only a layer of fabric stands between the sleeper and the weather. Light rain creates delicate taps. Heavier drops make the surface tremble gently overhead. The sound can feel near without feeling dangerous. The shelter remains still while the atmosphere moves around it. Rain in a forest has no single source. Some drops fall directly from the sky. Others strike the canopy and divide into smaller droplets. Water travels along twigs, gathers at leaf tips, and descends in stages. The journey from cloud to soil may take several minutes. A drop can pause on many surfaces before reaching the ground. Some water travels down trunks. Some remains inside moss or bark. Some is used by insects, fungi, and plants before it ever reaches a stream. The forest slows the rain and gives it many paths. Open grassland receives it more directly. Drops strike blades, soil, flowers, and small stones. Grass bends briefly beneath the weight, then rises again. Tiny droplets remain along the edges. They catch the first light when the clouds begin to open. Rain on sand disappears quickly from view. The upper grains darken as water spreads between them. Beneath the surface, moisture continues moving downward and sideways. A beach may look dry again while water remains hidden below. Rain on snow creates a different landscape. Liquid water enters the spaces between ice crystals. The snow may settle, become heavier, or slowly begin to melt. Rain can darken old snow by revealing dust already trapped inside it. The surface absorbs more sunlight and changes more quickly. Every surface receives rain in its own way. Stone holds a shine. Soil softens. Leaves gather beads. Rivers accept the water without showing where it entered. The same drop would behave differently in every place. Its path is shaped by whatever it meets. For now, the path can remain unfinished. The water can keep moving through dark soil, quiet streets, and sleeping forests. You can let the details become softer. The cloud can drift beyond the horizon. The last drops can rest on the window, and the night can continue without needing to explain where the rain will go next. Rain can travel through time as well as distance. A drop falling tonight may contain water that once moved through ancient rivers, forests, clouds, and seas. Water molecules are continuously reused. They evaporate, condense, freeze, melt, flow, and rise again through the atmosphere. The water itself does not carry a readable memory. Yet its movement connects the present landscape with countless earlier worlds. Some water once rested inside glaciers. Some passed through deep rock, where it remained hidden for thousands of years. Some moved through plants and animals before returning to rivers. The water cycle quietly joins living and non-living parts of the planet. A tree draws water upward from the soil. The moisture travels through narrow vessels inside the trunk and branches. When it reaches the leaves, much of it returns to the air. Tiny openings release water vapor in a process called transpiration. This movement helps pull more water upward from the roots. The tree becomes part of a continuous column reaching from soil to sky. In a large forest, many trees release moisture together. The air above the canopy becomes warmer and more humid during the day. Some of that vapor may later form clouds. Rainfall can therefore support forests, while forests also help support future rainfall. This relationship is especially important in tropical regions. Moisture may be recycled several times while traveling across a continent. A cloud can contain water that recently passed through distant leaves. The rain above one forest may partly begin in another forest far away. Nothing in this journey needs to move quickly. Water can rise invisibly, drift with the wind, and return days later. You can let that long movement continue without following every stage. The forest can breathe moisture into the sky while you rest. Rain also connects the atmosphere with the smallest living cells. Plants need water for photosynthesis, growth, and the movement of nutrients. Inside each cell, water helps maintain shape and pressure. When plants lose too much moisture, leaves may soften or droop. After rain, water pressure inside the tissues can slowly return. Leaves lift, stems become firmer, and growth continues. Some plants can detect water arriving near their roots. Roots may grow toward areas where moisture is more available. They respond to chemical signals, gravity, and the condition of the soil. Rain does not simply fill the ground evenly. It creates patches, channels, and gradients beneath the surface. One root may find damp soil, while another remains dry. Fungi can help plants reach more of this hidden water. Fine fungal threads extend through spaces too small for many roots. These networks exchange water and nutrients with plants. In return, the fungi receive sugars made by the leaves. Rain supports this quiet partnership beneath the soil. Most of it remains invisible from above. A wet forest floor may seem still. Below it, roots, fungi, bacteria, and tiny animals are responding to the new moisture. Some bacteria become more active after rain. They break down organic material and release nutrients into the soil. Others enter resting states when the ground becomes dry. The return of water changes, which processes can continue. This is one reason rain can make soil smell alive. The scent comes from chemistry, but it also reflects renewed biological activity. Earth beneath your feet is never truly motionless. It changes with moisture, temperature, air, and the remains of plants. There is no need to imagine the microscopic details. You can let the soil remain dark, quiet, and full of gentle movement. Rain can also reveal patterns already hidden in a landscape. Dry stream beds may begin flowing again. Low places fill first, showing the shape of the land. Water outlines paths that were invisible before the storm. A shallow depression becomes a temporary pond. A narrow groove becomes a silver thread moving downhill. These small streams may last only a few hours. Even so, they can carry seeds, leaves, insects, minerals, and soil. Temporary water can create temporary connections. Pools that were separated become joined for a short time. Animals may move between them, while the path remains wet. When the rain ends, the connections slowly disappear. The landscape returns to its quieter form, but small changes remain. Seeds have moved, soil has shifted, and underground moisture has increased. The storm leaves more behind than puddles. It changes what may happen days or weeks later. Plants may grow because roots finally reached water. Insects may emerge because the soil became soft. Birds may return because new food became available. Rain is often the beginning of events that are not immediately visible. The first drop may arrive long before the final response. In cold regions, rainfall can influence snow and ice. Warm rain may melt snow faster than warm air alone. The water carries heat downward into the snowpack. It also moves through spaces between ice crystals. This can change the density and stability of the snow. In spring, rain may help release water stored throughout winter. Streams become fuller as snowmelt and rainfall combine. Mountain water then travels toward valleys, lakes, and farms. The shower high above may affect communities far downstream. The connection is delayed, but the water continues moving. Glaciers also receive rain during warmer seasons. Some water flows across the surface in narrow blue channels. Some enters cracks and travels toward the base of the ice. There, water can influence how the glacier moves over the ground. Even a solid landscape contains flowing water. Ice, rock, soil, and air are connected by hidden paths. Rain on frozen ground behaves differently. If the soil cannot absorb it, water remains near the surface. It may flow quickly toward low areas or freeze again overnight. The same shower can create liquid water, ice, and vapor within a single day. Temperature decides which form remains. Water changes state easily compared with many common materials. This flexibility allows it to move through nearly every part of the environment. It can rise as vapor without being seen. It can float as cloud droplets. It can fall as rain, snow, or ice. It can rest underground or flow openly beneath sunlight. The forms change, but the cycle continues. The atmosphere contains only a small part of Earth's total water. Yet this small amount is constantly moving and renewing fresh water on land. Without evaporation and rain, rivers and lakes would not be restored. Life far from the ocean depends on water carried to the sky. Clouds act as temporary bridges between sea and land. They transport fresh water above mountains and across dry regions. The journey is powered mostly by sunlight and gravity. Sunlight lifts water into the air. Gravity brings it back toward the surface. Between those two forces, winds guide the clouds. The entire cycle can be described simply. Yet every part contains endless variation. No two clouds are exactly alike. No two storms follow the same path. No two drops meet the same surfaces on their way downward. Still, the overall movement remains familiar. Water rises, gathers, falls, and begins again. You can let that familiar pattern become quieter now. The scientific details can move farther into the background. Somewhere, moisture is leaving a warm ocean. Somewhere, it is gathering around a particle of dust. Somewhere, a small drop is growing inside a cloud, and somewhere else, rain is already touching the ground. It may be falling on an empty field. It may be moving through pine needles or across a quiet lake. It may be tapping gently against the window in a sleeping house. No one needs to watch the entire journey. The water will continue without being observed. The roots will absorb what they need. The rivers will carry the rest. The clouds will thin when their moisture is released, and the sky will slowly prepare to begin again. As rain completes its journey through the night, the landscape continues changing in small and quiet ways. Water settles into soil, gathers beneath leaves, and moves slowly toward streams. Much of this movement happens beyond sight. The clouds above are already becoming different clouds. Some droplets have fallen, while others remain suspended in the cool air. Wind gently reshapes the edges as the storm travels onward. A cloud does not empty all at once. It releases moisture unevenly, leaving some places deeply wet and others touched by only a few drops. Behind the rain, drier air may slowly arrive. The lowest clouds begin to thin, and faint openings appear between darker layers. The change may be almost impossible to notice at first. A distant part of the sky becomes lighter. The rain weakens from a steady sound into separate, softer taps. Water continues dripping from surfaces long after the cloud has passed. Roof edges, branches, signs, and wires release the rain they briefly held. These final drops are no longer falling directly from the sky. They are completing smaller journeys shaped by leaves, buildings, gravity, and time. In a forest, the canopy may keep dripping for hours. The tallest trees release water downward through many layers of branches and leaves. Moss holds the moisture close to the bark. Soil receives the rest, slowly filling the spaces around roots, stones, and fallen wood. A stream may begin to rise quietly. Water reaching it tonight may have fallen on hills and fields many miles away. Some of the rain will remain underground. It may travel through pores in stones so slowly that it returns to daylight years from now. Other water will rise again much sooner. A little warmth may lift it from a puddle tomorrow, returning it invisibly to the air. The water does not need to choose a destination. It simply moves according to the surfaces, temperatures, and gentle forces around it. There is no need to hold on to every detail now. You can let the water continue its journey without following where it goes. Rain has passed through every age of Earth's long history. It fell on landscapes that existed before forests, flowers, birds, or people. It gathered in ancient seas and moved across continents that no longer have the same shapes. The cycle continued while mountains rose and coastlines changed. It continued while life spread through oceans and slowly reached the land. The rain falling tonight is part of that same old movement. It feels immediate against a window, yet it belongs to a process far older than any human memory. Water has always been patient. It can wear away stone, fill deep valleys, and build new ground. One small movement at a time, a single shower seems brief. Many showers, repeated across centuries, can shape rivers, caves, cliffs, forests, and entire coastlines. The greatest changes often begin with motions too small to notice. One drop enters a crack. One thin stream carries away a few grains of soil. The process does not hurry. The land changes because water keeps returning, gently repeating its quiet work. Tonight, however, there is nothing that needs to change. You can remain still while the rain moves through the world around you. The facts can become less important now. They have carried us through clouds, forests, oceans, rivers, cities, and sleeping fields. They can drift farther away. Their shapes can soften like distant trees disappearing behind a curtain of mist. The names of things no longer need to stay clear. Clouds can simply be clouds again, and rain can simply be rain. You may still hear a few drops nearby. One reaches the window, pauses, and slowly joins another. The two drops become heavier together. They move downward, leaving a narrow trail that fades behind them. Another drop follows a different path. There is no pattern you need to understand, and nothing you need to predict. Outside, the wet ground reflects a little light. The reflections tremble when water touches them, then become smooth again. The night holds every sound at a comfortable distance, quiet gutter continues flowing somewhere beyond the room. Leaves release their final drops, one by one. Farther away, a stream carries rain to darkness without needing to be seen. The water knows no hurry. It moves around stones, beneath roots, and along the lowest places it can find. The clouds continue beyond the horizon. They may bring rain to another field, another forest, or another sleeping town. Here, the shower is becoming lighter. The spaces between the drops are growing longer. Silence returns gradually, rather than all at once. For a moment, one drop lands clearly, then another follows, softer than the first. The room remains warm and still. Nothing outside requires your attention. The rivers can keep flowing without you. The soil can hold the water it has received. The roots can drink slowly in the darkness. The oceans can continue breathing moisture into the sky. Clouds can form and disappear across places you will never need to visit. There's nothing more you need to follow. The rain can become only a distant texture now. It does not need to be a lesson or a story. It can simply be water touching the world. Your thoughts may come and go in the same gentle way. They can gather for a moment, then pass beyond attention. There is no need to finish any thought. There is no need to remember where the story began. The night is wide enough to hold everything unfinished. The rain is fading, but it does not need a final drop. Somewhere beyond hearing, water is still falling. Somewhere, a cloud is forming over a quiet ocean. Somewhere, a leaf is holding a single silver bead. The world can continue these small movements on its own. You can let your breathing remain easy and natural. You can let the weight of the day settle away from you. The window can stay dark. The clouds can move softly through the background. The last sounds of rain can grow quieter and farther apart. There is nowhere else you need to go. There is nothing more you need to understand. The water will keep moving. The night will keep deepening. And you can simply sleep.